Now for the last section of our multiple choice, which is linear functions. So this question is asking us for which set of ordered pairs is y not a function of x. Remember the way that a function works. Let's make a really basic one. Y is equal to 2 times x. So whatever I put in for my input, let's say I put in a 3, 2 times 3 means I'm going to get a 6 out. I could put a 3 into this function all day long. 2 times 3 is still always going to be 6. So every time I put in the same input, I should get the same output out. That is the definition of a function. If something happens so that I put the same input in, let's say I put a 3 into that function and I got a 7 out instead of a 6. That means that something's wrong. It's not a function. So to find something that is not a function, I'm looking for the same input with different output. So that means that it's not functioning correctly. So let's see what we got going on here. So 7, 10, and 5. Well, we don't even have the same input. So can't have this, so that's not the same input with different output. 7, 5, 10. Still don't have the same input. So it can't be that one. 5, 7, 10. Can't have it. 5, 7, 7. Here we go. So now we've got two sets with the same input, which is okay as long as they have the same output. But there's no such thing as a function that if you put in a 7, you'll get a 5 out, and then put in a 7 again and get a 10 out. So C is the one that is not a function because you have the same input with a different output. Number 14, which equation could produce all the values shown on the table? So I'm going to test this out first. So y is equal to negative 4 times x. That means I should be able to do x times negative 4 and always get my y value. Negative 1 times a negative 4 is a positive 4. Let's see, 2, oh, oops, sorry. Now 2 times a negative 4. 2 times negative 4 is not a negative 5. So this function rule is not the one that works for this particular table of values. Let's try a positive 4 because this says that 4 times your x values will give you your y. So negative 1 times 4 gives you a positive 4? Nope. So this one isn't right. The others require a little bit more room, so I'm going to put them over here to the side. So y is equal to negative 3x plus 1. So I'm going to put in negative 1x. So negative 3 times a negative 1 is a positive 4. I'm sorry, positive 4. Duh, positive 3. Positive 3 plus 1 is a positive 4. So it works for that one. Now I'm going to try the next value that's on my table. Oops. 1 equals negative 3x plus 1. Okay, so now I'm going to put in this 2. So negative 3 times 2 is a negative 6. Negative 6 plus 1 is, in fact, a 5, so it works for that one. Now I'm going to put in the 8. So negative 3 times 8 will give me a negative 24. Negative 24 plus 1 does, in fact, give me that negative 23. So this function rule right here, C, is the one that works for everything on the table. Last but not least, Moira placed $2 in an empty piggy bank and then added $3 every month. The same day, Nathan placed $5 in an empty piggy bank and then added $3 every month. The graph shows their savings. Which statement is true? The amounts in the piggy bank will never be the same. Let's see. So their rate of change is the same every single month because they're both putting in $3. So it's always going to change at the same rate. But Moira only started with $2, while Nathan started with more. So if Nathan started out with more money and they're increasing by the same amount every month, this sure is a good candidate. The amounts will never be the same. That's probably going to be it. But let's just double check and roll out the other ones. At the end of 5 months, the amounts in the piggy bank will be the same. Well, let's see. So Moira, at the end of 5 months, if she's putting in $3 every month, 3 times 5 is the 15 plus the 2 that she started with. So she'll have $17. Nathan is putting in $5 a month, so that's 3 times 15, or 3 times 5, which is 15, plus the original $5 that he started with. So at the end of 5 months, he'll have 20. So since he'll have 20 and she'll have 17, That can't be right. After the amount in each bank reaches $30, the amounts will continue to be equal. Well, no, they're never going to be equal because these two are changing at the same rate, but they started off with a different amount. The amounts in the piggy banks will always be equal because, okay, that's not going to be right either. They never started out equal to begin with. You can look on the graph and see. They never even started out as equal at all. So that can't be right either. So the one we were thinking originally is right. It should have been A. The amounts in the piggy bank will never be the same. You can tell by the graph and by their slopes, they are never actually going to become the same amount. They'll always just be, Nathan's will always be just a little bit more than Moira's.